Hello, in this video, we're going to study how to write equations, linear equations in different forms, how to find the intercepts of linear functions. We've done that graphically, but now we're going to do it from an equation perspective. And that makes things a little bit more difficult because it actually relies on more algebraic skills. Part 3 will be in a separate video, and that is linear regression. This is the part of modeling that you have for your course called Functions and Modeling. And this is truly the first thing that you absolutely have to use the TI-84 calculator. It cannot be done by hand. So if you have not gotten your calculator, this is a warning that you will not be able to do a third of section 2.1. But we're going to move on to how to write the various forms to write linear equations in. And you have the slope intercept form that you are already familiar with. And it's called the slope intercept form because M is the slope and B is the y-intercept. So say, for example, that you have a linear equation in slope-intercept form. Say you have y equals -1/2 x plus 5, and you're asked to find the slope. There's no work involved. There's nothing, no work or steps that you have to do, but you do have to remember to identify the coefficient of x as your slope. So the slope m is -1/2, and then b is 5. Another popular way of writing linear equations is called the point slope form. And that is y minus y1 equals m times x minus x1. Another form is isolating the y that got cut off there, but it should look like this: y equals m times x minus x1 plus 1. All we have done is we have moved that y sub 1 minus y1 to the other side. But it's called the point slope because, as before, this is the slope. However, that x1 and that y1 are actually just any point. So you have the point x1, y1. It's not the y-intercept. It's not any, it's not the x-intercept. It's just any point on the line. So say, for example, that you are given this equation, y minus 3 equals -2 times x plus 1, and you're asked to find the slope. So this is still the slope. The slope m is a -2. And you're asked to identify a point on the line. And from the equation, we do have to be careful because we're going to have to take the opposite of -3 for the y value and the opposite of +1. So this other point on the graph for x, it will be a -1, the opposite of the +1. And for the y, it will be a +3, the opposite of that y value. Then the last form that we use is called the standard form, ax plus by equals c. And it's not exactly a typical equation that is used to write your final answer in. It's more the kind where you're given the linear equation in that particular form. But one thing that you do need to know about that is that A, B, and C are integers. What does that mean? It means whole numbers that are positive or negative. In other words, no fractions, no decimals. So let's say we look at an example, and it could be something like negative 2x plus 5y equals 10. And again, it doesn't reveal this form, the standard form, doesn't reveal any information right off the equation. It doesn't give you the slope. It doesn't give you a y-intercept. It doesn't give you an x-intercept. But you're going to find out soon that it's very common that they give you the equation of a linear function in this format, and then they ask you to write it maybe in the slope intercept form, or they ask you to find certain points on the graph. It's just a very common way of expressing linear functions, even if it's not our final answers for a linear function. Okay, so now we're going to move on to finding the equations of lines using some of these forms. So it says find the point slope form. So that's going to be, I'm going to write it here. The point slope form will be that y minus y1 equals m times x minus x1 of the line that is satisfying the following conditions. Use the point given as x1, y1. So the given conditions are right here. We're given that the slope is a negative 1.3. So that's m equals negative 1.3. And it passes through this point. So this will be my x1 and my y1. So as it turns out, we know everything we need here. We know y1, we know m, and we need x1. So what we're going to do is we're going to substitute y1. We have y minus y1, and that's a 6, equals m, which is a negative 1.3, times x minus x1, but x1 has a negative 2. And really, the only thing that you need to do here is actually get rid of that double negative. So we're going to have y minus 6 equals, you do not need to distribute the negative 1.3, and then that becomes an x plus 2. And this is what we call the point slope form of the equation of a line that has a slope of negative 1.3, and it passes through the point negative 2, 6. In a way, the next part is almost like a whole new problem. It says then convert the equation to the slope-intercept form and write the formula for the form F, whose graph is the line. So part 2 is asking you to convert this equation into the slope-intercept form, and that's y equals mx plus b. So we're going to change this equation into this format. And if you notice, in the slope-intercept form, you have y by itself. So what it really boils down to here is some algebra steps, because we're going to need to, first of all, we're going to need to distribute that negative 1.3. This is a multiplication. So you're going to multiply negative 1.3 times x and negative 1.3 times 2. Meanwhile, I'm going to bring the y minus 6 here. So negative 1.3 times x will give me a negative 1.3x. Negative 1.3 times 2 will give me negative 2.6. We're almost there. I can see the slope already. That's negative 1.3 in front of the x. but I need to have the y by itself. So now what we're going to do is we're going to add 6 to both sides. On this side, they cancel out, and it leaves you just the y. Here we have negative 1.3x, and I have negative 2.6 plus 6, and that's going to give you plus 3.4. And this is what we call the slope-intercept form of the same line. The line that has a slope of negative 1.3, and it goes through the point negative 2.6. Now, part 3 says write the formula for a function f whose graph is the line. So that sounds kind of different and confusing, but it says find the formula for f of x. F of x and y are the same. So all you're doing here is instead of writing y, you write f of x, but the equation itself doesn't change. It's still going to be negative 1.3x plus 3.4. And that will be the function formula for the line. Okay, here we have another type of problem. In a way, they're asking you some similar questions. They want you to find the slope-intercept form of a line that satisfies those conditions. So you want your final answer to look like this. However, I don't have the slope and I don't have that y-intercept b. Now, these are the conditions for the line, and it passes through those 2 points. So I could find the slope by taking this to be your x1, y1, your x2, and y2. I can find m, the slope, with that formula that has the difference of the y's over the difference of the x's. So I'm going to go ahead and set that up. So I have y2, which is a negative 3, minus y1, which is 6, divided by, now we have x2, which is 2, minus, then x1, and x1 happens to be a negative 1. You cannot really do this all on the calculator unless you set it up as a fraction. Then it will reduce it. The calculator will reduce it and keep it as a fraction. But you could do certain parts with it with the calculator real quick. For example, negative 3 minus 6 will give me a negative 9. And then 2 minus a negative 1 becomes 3. It's 2 plus 1. So then that's going to become negative 9 divided by 3, and that would be a negative 3. So I have the slope, but I don't have b. B is the y-intercept. That doesn't mean just the y value for a point. It means the y value for the y-intercept. These are not y-intercepts because x are not 0. So my b is not a 6 or a negative 3. I have to find what that b is. So I'm going to use the point slope formula. Using m that I already found in step 1, which is a negative 3. Then I'm going to select the first given point. I could select the second one, but I'm going to take the first one. So I have a negative 1 and 6. And now remember the point slope form is y minus y1 equals m times x minus x1. And I have everything I need here, so I'm going to substitute y minus y1, and y1 is a 6, equals m, which is a negative 3, times x minus x1, that will be a negative 1. So the first thing I do is I take care of the double negative here, so that will be y minus 6 equals -3 times x plus 1. Then I'm going to distribute that -3 to x and to 1. So I have y minus 6 equals -3x minus 3. And then in the last step, I'm going to actually change that to, I'm going to isolate the y. So I got the point slope formula here, but the last step is to convert it to slope-intercept form because they ask you to write your answer as a slope-intercept form. So I do continue here by adding a 6 to both sides. So then here the sixes cancel out on the left-hand side. So then I am left with y equals. Then I have -3x, and -3 plus 6 will be +3. And that will be the slope-intercept form of this equation. I'm going to make this a little bit smaller so we see all the steps. So first we found the slope using the 2 points we were given. Then we found the equation using the point slope. And then last, we isolate y on one side to write it as in the slope-intercept form. Okay, so the next part, you're going to start seeing some graphical, approaches, because in order to understand this idea of vertical and horizontal lines, it's easier to see it virtually, visually. Now, these are kind of the exceptions to the equations. The equations of a line is y equals mx plus b. Sometimes the b might be missing. So you may have something like y equals -2x. That will still be a line, slanted line. However, there are times when you only have x and you only have y. So vertical means a line that goes straight down and up. And that is always x equals a number. And you have to have the x in order to be an equation. So an example would be something like x equals -2. So here are the x's, here's the y-axis. So I locate x equals -2, and it's right here. But the line x equals -2 is the line where x is always a -2. No matter what point you're looking at, x is always a -2. And that makes it straight vertical line like this. But it has only x equals -2. The other exception to the rule is a horizontal line. That's like the horizon, so it goes to the right and to the left. That always has the form y equals a number. So an example would be something like y equals 3. So here is the x-axis, here is the y-axis. When I locate y equals 3, I see it right here. But the line y equals 3 is where the y is always 3. No matter what point you look at, no matter how you change the x, the y value is always a 3. So it's actually what we call a horizontal line. The horizontal line y equals 3. So those are the exceptions to this equation of a linear function. They're still linear functions. Now, notice that the horizontal line will pass the vertical line test, so it is a function, but the vertical line will not pass that vertical line test for functions. So it's not a function at all. Okay, next we're going to look at the intercepts of the linear function. And this is the rule for any type of equation. When you are looking for the x-intercept, you set y equal to 0 and solve for x. When you're looking for the y-intercept, you set x equal to 0 and you solve for y. Also, when you're looking for an x-intercept, then you're looking for some number here, x, but the y value is 0. When you're looking for a y-intercept, x is 0 and you're looking for a y value. That's true for any type of equation. But of course, we start by applying it here to linear equations. So we're going to look at an example here. I'm going to make this a little bit larger. And it says determine the x and y intercepts on the graph of the equation, and then graph the equation, preferably using those points that you just found. And so this may not necessarily be a graphing calculator type of question, but it is a graphing question. Notice that it is in standard form. So it's actually very common that they give you a linear equation in standard form, but you don't have to necessarily isolate the y or change it in another form if you're just finding the intercepts. So I'm going to start with the x-intercept is the opposite. We substitute y for 0 in the equation. So I have 5x plus 2y, but instead of y, I'm going to put a 0 equals negative 20. When you multiply 2 times 0, that will give you 0. So in a way, it makes this term disappear here. So we have only 5x equals negative 20. Then you divide both sides by 5, and that gives you x equals negative 4. So the x-intercept will be the point negative 4 for x and 0 for y. Now, when you're looking for the y-intercept, we do the opposite. X equals 0. So we substitute x for 0. So instead of 5x, we have 5 times 0 plus 2y equals negative 20. Then this term will disappear because 5 times 0 is 0. And that leaves me 2y equals negative 20. You divide both sides by 2, so that will be y equals negative 10. Then the y-intercept will be the point 0 and negative 10. So now I'm going to use these 2 points to graph the function. I can see that I don't have enough room for the negative 10, but if you're doing this by hand, then we can actually extend that. So I'm going to make more divisions here and more room. So here is the x-axis. Here is the y-axis. The point negative 4, 0. The x is negative 4. And the y value is 0. So that point would be right on the x-axis. That's why it's called the x-axis. Now the other point has 0 for x and a y equals -10. So I extended it because I had only to a -5 here, and I need down to a -10. So I'm going to make another 5 divisions. So the point 0, -10 will have x equals 0 and a y equals -10, and it will be right here. So now I'm going to connect those with a straight line. I always have trouble with making this a straight line, even with this nice tool. So I'm going to adjust it. I'm going to save it. And there you have the line. I have one more question. And this one is also finding the x and the y intercepts. This one is not really truly the regular standard form, but that's the way that is given to you. 5x over 6 minus y over 2 equals 1. And you're asked to find the x and the y intercepts. You don't have to rewrite the equation or change it just because you have some fractions here. So we're going to use the same rules. You have for the x-intercept, y equals 0. So I'm going to go ahead and substitute into this equation y for 0. So I have 5x over 6 minus y, which is 0 over 2, equals 1. But that is also 0. 0 divided by 2 will actually give you 0, and that leaves you 5x over 6 equals 1. There are different ways that you could isolate that. You could multiply both sides by 6 and then divide by 5, or you could think of multiplying by the reciprocal, which is 6/5. So what happens is the 6's cancel out, the 5's cancel out, and it leaves you just 1x. X. On the other side is 1 times 6/5 will just be 6/5. So the x-intercept will be 6/5, and the y value is a 0. Now, if you see this, and you think maybe dividing by 5/6, if you think of it that way, that's also correct. And you could actually use the calculator to do your operations. But 1 divided by 5/6 is going to give you back the 6/5 that you see there. Now, for the y-intercept, we substitute x for 0 into the equation. So we have 5 times 0 over 6 minus y over 2 equals 1. First of all, 5 times 0 will give you a 0. 0 divided by 6 gives you a 0. But be very careful here because that makes this term disappear, but the minus stays in there as a negative. You have negative y over 2 equals 1. So if you rather think of it as a negative y over 2, and then multiply both sides by 2. You could do it that way. That will give you negative y equals 2. Like here, just think about 2 times that and 2 times that. This is 2 over 1, so the 2's cancel out, and it leaves you negative y equals 2. But now you need to get rid of that negative in front of the y, so that's a negative 1. So you divide or multiply by a negative 1, and that's going to give you y equals a negative 2. So then your y-intercept will be 0 and negative 2. So this video or this exercise concludes the what parts 1 and 2 really of section 2.1, writing linear equations and finding intercepts. So you could start your homework for section 2.1 at the end of this video, but we still have linear regression to do, and that will be on a separate video. So good luck with your homework here. And this were the x and the y-intercepts for this equation. I'm going to make it smaller so we see the steps for both the x and the y-intercept. So good luck with the start of section 2.1.